Okay, we're on to our penultimate piece of factorising here. I'm going to start again by getting you to expand some brackets to remind you of some stuff, so you should pause here and then you should wait to come back. So please pause, do these yourself. Pause, 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 and you've paused and you've pressed play, so you've done it yourself in between. We should have written some steps in between. I'm going to highlight one of the key steps before we get to the final answer as well. So we should have seen 2z squared take 10z plus 3z take 15, and that's collected to be 2z squared take 7z take 15. And then this one will have got 4y squared plus 12y plus y plus 3, which would have simplified down to 4y squared plus 13y plus 3. Now, something looks fishy there. No, that seems good to me. So, previously when we factorised, we were looking for things that multiplied and added to the same thing. You can see that's not going to work here, because whilst 3 5s are 15, 3 add 5 isn't 7, or 3 take 5, there's no way of using that to the 7. This 2 is clearly doing some work. So in a similar way, 1 times 3 is this final 3 here, but 3 and 1 doesn't make 13 in any proper maths way. I mean, concatenation exists, I suppose, but that'll be a bit over the top. What you might notice though is that 2 15s and 3 10s are both 30, and 4 3s and 12 1s are both 12, with some negatives floating around up here to pay attention to. So if there was some way of splitting this up back into those two, we could find that quite useful. And the target, it looks like, is these two products. So 30 and 30, 12 and 12, and that's what we're going to do. So that's how this value at the front that isn't 1 anymore gets involved. So we know that whatever I'm splitting this into multiplies to whatever these multiply to. So first things first, we're going to take this and this together and do 3 times positive 10 to get positive 30. Okay, so now I've got to find myself 2 target numbers that multiply to positive 30 and add to positive 11. Because on the previous page, whilst these do multiply to that, they also add to that, because that's what collecting terms is. So, multiply to 30, add to 11. Hopefully we've all spotted that that has to be 6 times 5 and 6 plus 5. And in this case, they're all positive, to try and keep the first one easier. And that was to find us what these 2 terms in the middle were. So this middle term we're going to split back up, so we have 4 terms. So the first term is still going to be 3x squared. A little bit of space there. And then we're going to make 11 into a 6 and a 5 plus the 10 at the end. So we've split that 11 there into 6 and 5. And that's the right choice because it also multiplies to this 30. 2 and 9 won't work, 10 and 1 won't work. Now we should, at this point, have spotted something reasonably useful. Those 2 terms factorise in a fairly basic way. They both contain, in this case, the common factor of 3x. So 3x goes into that x times, and it goes into that twice. And these both contain a factor of positive 5. How many 5s are in there? Well, x, and how many 5s are in there? 2. So that's some separate factorising going on there in these 2 separate terms. And you'll notice that these brackets are the same. That's a benefit, that's a success, because that means that's one of our brackets. So x take 2 comes out the front. Take 2, that's just not reading, x plus 2 is what it says. And that leaves behind a 3x there and a 5 there. And those are our 2 brackets. If we multiply those back out, we would in fact get this thing at the top here. Now that's a bit of a fiddle. It's not straightforward, but it will always get the right result. If we do one more together, we've got half a chance of doing this. So first step was these two to see what it gets. So 12 lots of -2 is -24, and now I've got a bit of a numbers game. What times what is -24, which also adds to +5. And that's just knowing your times tables and being able to do some calculations in your head. Hopefully you are all spotting a 3 and an 8 floating around. I'm going to do it that way around, I think. 8 times 3 is 24. It's not negative though. And 8, maybe not. Put some negatives in there and all comes good. 8 times -3 is -24. 8 take 3 is 5. So that's the right splitting of the middle term. That makes 12w squared plus 8w take 3w take 2. Again, we've just split that middle 5 into an 8 and a -3 so that we can make these things match up. We're looking for some simple factorisation now, so what divides into both of those? A lot of w's, 4 w's I think. So 4w lots of 3w plus 2. And then this is a bit of a fiddly one, which is why I've chosen this example. That shares a factor of -1. And in fact, sometimes a factor of 1 is actually useful to write. But here they're both negative. So this is -1 lots of 3w plus 2. You don't normally write a 1 when you're multiplying, but this is useful here because I'm going to take it as a factor later. And because I took that -1 out as a factor, we've now got the same two brackets here, which leaves 4w take 1 as one bracket and 3w plus 2 as the other. There will be some of you who in your head can try maybe 2 times 6, maybe 3 times 4, maybe 1 times 12, along with 1 times 2, and add them all up and basically expand this in your head to check that it's correct. That's absolutely fine, but it is risky if you get those wrong occasionally. But there are some of you in the world who can just see that and write those down because you can do all of this in your head. Well done you. The rest of us mere mortals need to have some method to fall back on, and that gets us there. So we can now factorise any quadratic, assuming it actually factorises, using this method or the simpler method from the other video. Have fun!